And welcome back to PyCon AU education track for our next talk. It's an exciting one. I am very excited. I have the pleasure of introducing Brad Nielsen with our next talk about a website-controlled Lego robot using the Raspberry Pi. Now, I have a fantastically long and detailed bio that Brad has requested I don't read. Not quite. Brad has a really wide variety of experience across development, web development, software designing, but has also been a teacher for, I believe you said, a bunch of years. And has been doing a lot of really interesting stuff in looking at educational design and learning management systems. And I'm really I'm really keen to hear about all of the things, to how that works into Lego, Raspberry Pi, and awesomeness. So, Brad, away you go.
Okay, thank you. So I'm really excited to present here at PyCon as well. In fact, I was looking for some kind of conference to present this project at, and a lot of conferences had been cancelled, so I'm really happy that PyCon wasn't. This project I'm going to present on, it's been the fruition of a number of years of work. So I've been teaching now at Marist College for about, about 8 years. And right from the beginning, we introduced Python into the school. And we then had to develop a program around Python that would suit every grade thereon. So you can see on the side there, I've got the different streams of stuff that we teach at Marist College. And a lot of this is actually mandated by the syllabus. So we're teaching Python programming, we're teaching web development, and we're teaching databasing. And we were also teaching robotics. And I find students are attracted to different things. So some kids just love using Pygame and developing computer games using Python. Other kids just love creating websites. Some kids really love the databasing. And then finally, we have a bunch of kids who really enjoy the robotics. And that love for robotics, actually, it actually becomes a little unhealthy at times, because all of a sudden they name their robot, it becomes their pet and their friend, and they're constantly talking to their robot. And it's just a really fun project for kids to learn about programming with. And what happens this year is that the new Queensland syllabus came in, and the new Queensland syllabus pretty much required most projects to involve SQL in some way. Prior to that, I always had like a 5-week unit on robotics for my year 12s, and that was using EV3s and Robot C. And I was never happy with it. I love the fact that kids really got into it, but I was never happy with it because it was a 5-week project, and it was really, really quite simple. The only good thing about it was it was really quick. It was really quick, and as a small little project for year 12s, it kind of suited that particular time slot. So the new syllabus came in, and knowing that everything had to involve SQL in some way, and interface design as well, then I thought to myself, well, do I ditch the robotics project, which is what a lot of schools have done. A lot of schools in Queensland now are just doing web apps in some way. Do I ditch it, or do I find a way to work with the robots and try to get the web application working with it? And in my own mind, I kind of thought, I can do this. So we changed the 5-week robotic task into a 10-week Internet of Things task. And I submitted the project. It gets endorsed by the curriculum authorities here. I submitted that late last year, not actually fully knowing if I could make it work. But in my own mind, I thought, I kind of think I could get this working with my students, and I think they'd really enjoy it. So one of the things that I had to look at was, how do I get a website working with the EV3s? Because one thing about Lego is Legos are very flexible. The kids can create lots of different Lego designs that you can suit different projects for. So the flexibility of Lego is great. The problem is with the actual bricks themselves, they don't have inbuilt Wi-Fi, they don't have video cameras. They're quite limiting. At least they were at that stage. I'm not sure whether the next versions of EV3s are going to be better. However, through Robotic Club, we'd been practicing with these things called the Raspberry Pi. And the good thing about the Raspberry Pi is you've got your Wi-Fi, it's compatible with a whole lot of different sensors, and it's pretty much its own operating system. So it's so much more powerful than an EV3 brick is. So if I could replace the brick with the Raspberry Pi, then I can do all that amazing advanced stuff that I know my students would be capable of. And the way we did that was we purchased an adapter called the Brick Pi. So over in the United States, there's this really good company, although they were called Dexter Industries. Now they've been taken over by Modular Robotics. Together, that company produces this adapter that you can plug onto the Raspberry Pi. And that adapter allows you to plug in Lego sensors and connect Lego to a Raspberry Pi. So I've got the price there for it. The only thing is it doesn't include the EV3s themselves. But in some ways, I've leveraged it so that I've already got the equipment for the Lego robots. We've got about 22 Lego robots at my school. So it didn't cost that much to then get the Brick Pis and the Raspberry Pis which come with it as part of that package. So I've kind of saved myself money as well. Okay, so what that meant is now, in terms of system, I can have a Lego robot, but I can also connect it to a web server. And I've presented at PyCon before on a web server called Flask, which I think is the best Python web server for students to learn from. And that web server can connect to an SQLite database. Both Flask and SQLite come now packaged with Python. So you actually, once you install Python, you get Flask and you get SQLite. So it's pretty easy for students to work with. And the Raspberry Pi is by default installed with Python as well. And because you've got wireless capabilities, you can then connect to a wireless network and, in fact, even work over the internet. So you've now got an internet-capable robot that students can program with that can also include things like a PyCam, which is video or pictures, and other sensors. So one of the things I also did was we purchased IMU sensors. An IMU sensor is like an advanced gyro sensor that can give you compass, acceleration, etc., etc. And we also purchased a thermal sensor as well to go with it. And the thermal sensor was great because it allowed us to do the following project. And that's what I'm going to present on, is the project that my students did. So we had to come up with a scenario, and we're mandated by the curriculum authority to try to come up with some type of real-world scenario. And this was actually just at the same time as the bushfires were going throughout Australia. So I was inspired to create some type of fire search and rescue robot. And the scenario was that the students had to get their robot to be able to navigate a maze, rescue victims, and the victims were actually something cold, like an ice pack. They had to map where the fires were, and the fires were represented by candles, although I actually replaced the candles later on with a heater. And they also had to be able to, so they had to save the victims from the fires, essentially. You'll notice that the maze there, I've got red dots. I actually replaced that with red tape squares later on. So one of the things about maze finding is that it's a lot easier for a robot to navigate a maze if they can actually know where the junctions are. So I'm trying to make it a bit easy for them, but at the same time, I wanted them to be able to do automated searching. And the students were actually encouraged to either do manual searching or automated searching with their robot. The most important thing is they had a website that connected and controlled their robot, and that website had the controls for manual searching and automated searching. And if they were going to do manual searching, they were expected to have some type of video point of view for the robot and some type of mapping as well. The students themselves have to do, the project requires a massive folio. So it's actually like 14 times A3 pages, which includes their code as well. And they have to do a small little video demo, which I'll show off one of my students' work later on. Oh, well, here's the demo here, actually. I'm not going to go into the code too much. I'll talk more about the coding later on. So this is a demo of a student's work. And I'm going to say a lot of my students, they didn't put a lot of effort into their presentations because they were putting so much effort into actually getting their robots to work. So the presentations were kind of like a quick thing as an afterthought. But this student, I was really impressed because he got his automated searching working and his website was fantastic as well. So here's his work now.
This page here is the first page that the user is greeted with when they go to access the website. It is the login page and incorporates the use of the Queensland Fire and Rescue Service logo for some aesthetics with a fire background. All they have to do is click user details and submit to log in. When the user logs in, they are then taken straight to the mission control page. This is how they will be able to start recording a fire at a past location or enter a new location to start recording the fire. This is also where the robot will be controlled from and the path will be displayed as it travels through. This page here shows all past fire information. For example, if the user was to select this fire details here, it shows them that the robot was being operated by the user admin. This fire occurred on the 20th of the 5th, 29 at 14:16:42. It then shows the map of the robot went. It went forward, detected a junction signified by the red small square, then also it detected a fire at that junction signified by the orange triangle, went right, and then went right again. This here is another fire. In this instant, the robot just simply went forward and detected the victim was there, fired by a green square. There's also a sensor view page. This here is where all sensors of the robot are able to be displayed and are shown in live time. Back to the topic of fires. The user has the ability to select past locations and use these to start recording a fire. It should be noted that the page has now changed so that there is a live feed coming from the robot's perspective. And it should be noted that the latency of this is actually pretty good. The user has the ability to enter a new location if they would like, using these input boxes here.
Turning left. Turning right. Turning around. Closing claw. Opening claw.
As you just saw, the robot's key functionality includes the ability to move forwards, turn left, turn right, and turn around, as well as being able to open and close the claw on the front of the robot. As you could also tell, it played music as the robot went forward and also spoke any commands that were executed. The robot is now executing its automated search function, where it moves forwards until it is stopped by a wall or junction and then follows the left-hand wall until it finds the victim and then grabs it. Now that the robot has collected the victim, it will now follow the right-hand wall back to the point that it started at. Thank you for listening, and I hope you enjoyed.
Okay, so you can see the project there. That student's done an amazing job just in terms of the level of programming. So you can see that he's got his website connected to the database and it's controlling. He's also mapping the fire and he's got video set up as well. So it was a very challenging project. And it's for the actual year 12s, it is their biggest project that they do that year. So it kind of, I'm proud of their work because it's the culmination of 5 years of learning Python, JavaScript, web development, all that kind of stuff. But there were challenges in terms of getting the project going. One of the challenges for myself is I've still got lower end students in my class who for them, I've still got to cater for their needs. So, and one of the things is I needed to make sure that the functionality is going to work quite easily. I need to make sure that the functionality would be accessible to what they're doing. I didn't want students to lose motivation because their robot wasn't moving. So I created myself, or created them, a Flask template because that's the web server that's operating on their Raspberry Pi. And the Flask template pretty much had all these really simple functions available to them. The most simplest being move forward, stop. I also took a lot of the code that Dexter Industries had for the Brick Pi, and I wrapped it up into an interface object for them. So I tried to make it so that they could pretty much tell the robot what to do, and then they could focus more on things like the automated search and retrieval. Because one of the things was once you retrieve the victim, it's got to then retrace its path back. So I tried to make all the functionality as accessible as possible to them. That included wrapping up the SQLite functionality inside a database interface. And then inside the actual web template, I've embedded Bootstrap, jQuery, and Ajax. I even embedded JavaScript Turtle as well. So just a way of drawing on the screen. So that's all there. And by all means, you can actually have a look at my code because I've placed it up on a GitHub. Other issues that I had, sometimes the sensors had a loading time. So when you actually run the robot, you have to kind of wait for the sensor to have loaded before you actually access that data. So if you accumulate all that sensor loading time, you get about 4 seconds before the robot's loaded, which wasn't much, but I had to keep telling students, don't tell your robot to wait for 4 seconds. Threading was a big issue as well, because a web server is creating threads for every request that is being made from the student. So a student's actually making all their requests using JSON. They're still having to manage, okay, if the robot's being told what to do at a certain time, you don't want to give them a conflicting message at the same time. So for me, I tried to take care of all the threading inside my template that I created for the students, and that worked pretty well. I still had a small issue with the IMU sensor, where if you actually reloaded the page several times, the IMU sensor would get out of configuration. And then finally, there was some bizarre error where the thermal temperature sensor, which is the thermal camera, it turned off the motors as soon as it was turned on. It was actually kind of weird. So as soon as it was configured, the thermal temperature sensor turned off the motors. So I had to, unless you're reading, I should say, if you're reading from the thermal temperature sensor, the motors turn back on. So I actually created a background thread that is forever reading from the thermal temperature sensor just to keep the motors going. But it all worked. The students aren't even aware of this. Although I did have one student try to create his own API. So he found the same problem and I had to say, okay, this is what's happened here. And then finally, the other issue was COVID-19. Students had to work from home a lot, initially in the beginning anyway, for the first 4 weeks. So I only had 20 robots and I've got 26 students. And I didn't have as many batteries either. I only had like 15 batteries. So getting them to operate their robot from home and connect to their Raspberry Pi via their network took a lot of my time, just because they were working from home. But to wrap up, it was worth the effort. I'm really, really proud of what my students learnt. The actual individual skills and stuff that they had to learn as part of this project, it actually kind of boggles my mind, actually, because they've had to do a bit of GitHub, they had to learn a bit of Linux, they had to learn a lot about networking, because a lot of times they were programming their robot using VNC. So they were programming their robot from across a network. They learnt more about Flask, and they did a lot about the JSON and the Ajax and the JavaScript Turtle. It was a project that was full of rich learnings where they had to take all these different concepts and apply them together. And my students rose to that challenge. So I'm very, very impressed with their work. Thank you. So I think I've got time for questions now.
Yes, Brad, thank you so much. I thoroughly enjoyed that talk. There have been some great questions. I know it's not traditional, but first I'm going to start with some of the comments. There were a lot of comments like lucky kids, and really people being really excited about the project, but also a few people saying that they now know what they're going to do this weekend. So I think that's fantastic. Some of the questions we got, maybe we can start with this one, is what you did to manage the Raspberry Pi's limitations without analog inputs. I know it's a tricky challenge.
Because the Brick Pi was on top of the Raspberry Pi, I didn't have to manage analog inputs. All the sensors went through the Brick Pi, so it took away a lot of the difficulty. Mind you, we've done lessons on the Raspberry Pi and analog inputs back in year 11. Right at the end of year 11, we kind of do that. But in terms of their project, it was more software based actually than having to worry about individual pins and stuff.
Great. That sounds great. One of the other questions was whether you bought the Lego sensors separately or whether you used the NXT kits. I don't know which is more cost effective if you happen to know.
We use I've got all the EV3 kits, but I really wanted those the thermal camera sensor and the IMU is what we purchased individually, and they both were available from Dexter Industries. And they were great. And because they were from Dexter Industries, they worked straight away with the Brick Pi. But just a quick note, a temperature humidity sensor isn't as effective as a thermal camera. So if you're in a fire thing, initially I thought, temperature sensor will be fine. But because heat diffuses outwards so much, you get like a 1 or 2 degree heat increase when you're close to a fire. Whereas the thermal camera actually tells you what the temperature of the object in front of it was. So that's why I panicked a little bit initially when I thought, oh no, I've got to do something different here. But the thermal camera was great.
I mean, what's a good project without a little bit of panic? If you expect the students to panic a bit, it may as well include us as teachers panicking a bit as well.
Well, that's the thing. I came up with the project before knowing it was actually going to work. So there was a lot of problem solving.
It's one way of maintaining interest and focus for us as teachers, just sort of flying by the seat of our pants. One of the other questions from earlier on in your talk was why the focus on SQL? I don't know if you want to speak to that around the... I'll let you go.
It's actually just in the syllabus. The new syllabus that's come in, SQL is in units 2, 3, and 4. So there's 4 units in senior, and SQL is in each one of those units. So I thought you kind of have to put it in your project. Otherwise, if you didn't put it in your project, then they're going to get to their external exam and not know it well enough. So, and you still had to store data anyway. So it was more of a syllabus thing, but it worked quite well. Like I said, SQLite's quite easy to use. And once I had created this database wrapper, it was as simple as the students just writing modify database and they write the SQL query. It did it for them. So, yeah.
Great. And it is always nice to have, if you're going to be teaching concepts to students, to have that, them enact that into some kind of a real world project, so they get a sense of what it's useful for more than just the exam. So there's certainly some nice elements there.
Yeah.
Great. Well, that's about all the time we have for, if there are more questions, I think Brad will perhaps join us in the hallway track afterwards. But for now, it's time for a bit of a lunch break. So thank you very much, Brad. We've got our Auslan claps. We have a long break now before we come back for our next speakers. That means, in fact, I'm getting a dinging of the timer. Adelaide time, the conference goes back, we'll come back at 12:45. For those of you in other time zones, please readjust. But you've got about a little bit more than an hour before we come back and we go into the afternoon session of PyCon. We hope you all find your own lunches up to conference standards. And we'll see you again soon. Thanks very much.